Let's continue our discussion of fractions with what we need to learn about multiplying fractions in Lesson 21. And I've written some steps to multiplying fractions up here for you, which will make more sense as we go through the examples. But I want you to have these steps so that you can jot them down on an index card and make your own notes so that you understand what they're saying. In other words, don't use my words if they don't make sense to you. Write your own explanation down. The first step is going to be reduce, cross-reduce. Remember, you can always reduce an individual fraction before you multiply, but you can also do something when you're multiplying fractions, which is cross-reducing, and I'll show you that in a minute. The second step, multiply the two numerators together, or the numerators all get multiplied. Then next you would multiply denominators, and finally reduce if needed. If you are successful with reducing fractions in the beginning of step 1 and cross-reducing, you won't have to do any reduction when you get to step 4. Also, your multiplication will be a lot easier. You'll be dealing with smaller numbers. So let's look at example 1, which says 5/9 times 7/4. Well, we look at this problem as numerator times numerator over denominator times denominator. In other words, it's really 5 times 7 over 9 times 4. Now, because of what we just did with reducing prime factors, you know that you could cancel out any of these if they matched. I don't have anything that matches, and the only factor that's not, or the only term that's not prime is 9. It would be 3 times 3. There's nothing that's going to match in any of these. So we're just going to multiply 5 times 7 for 35, and 9 times 4 is 36. And I know that's my lowest form because there was nothing I could reduce. Take a look at example 2. In example 2, I've got some things that possibly could be reduced. I'm looking at 18x, and I'm looking at over 20 times 36 over 99. Now what I want you to think about is, do you have any factors that are common to both 18 and 20? And you do. You could reduce 18 and 20 by the number 2, couldn't you? You could also reduce the 36 and 99 by the number 3. 3 would divide into both of those. In other words, if we factored them down to primes, we'd find 3's in both of them, and we could cross them out. We could also cross-reduce. We could reduce 18x and 99 by the factor of 9. We could reduce 36 and 20. We could divide both of those by 4. So that's what we mean when we say we can reduce fractions. Any fraction, any number, numerator and denominator we can reduce. But when we're multiplying fractions, we can also cross-reduce. Let's do this cross-reducing and show you what happens. If I decide to reduce 18 and 99, I would divide both of those by the greatest number I can think of that would divide into them, which is 9. 18 divided by 9 would give me, a 2. So the 18x divided by 9 is 2x. When I divide, I have to divide the denominator by the same number, so I have to divide this 99 also by 9. And that gives me an 11. Well, let's take a look at 20 and 36. Both of those we can divide by 4. 20 divided by 4 is 5. 36 divided by 4 is 9. Now, I don't see anything else I can reduce, so I'm going to multiply numerators. I'm going to say 2x times 9, that's going to give me 18x. I'm going to say 5 times 11, that's going to give me 55. Now look at it again just to check and make sure, but that's the lowest form. I can't reduce those fractions anymore. And I've multiplied by two fractions. Example 3 is a whole number. 3a squared times 1/4. Well, anytime you're working with fractions, you don't want to work with a whole number of fractions. You want two fractions. So here, let's make it a fraction. We'll put it over the number 1. Now, look and see any reduction that you can see. I don't see anything that could reduce or cross-reduce in these, so we're going to multiply numerators. 3a squared times 1 would just give us 3a squared. And 1 times 4 would just give us 4. That would be the lowest form of that particular fraction. Let's take a look at example number 4, and it might get a little confusing with all the x's, so let's just kind of write this out for you. If I said the first fraction is really equal to x times x times x over y times y times y, and I know that I'm multiplying it by the second fraction, and I know I can multiply and write everything in numerators and everything in denominators, so it's y times y for y squared times x down here in the denominator. Okay, so what I did, I multiplied numerators times numerator, denominator times denominator, and I wrote it out in primes. Because it was a little easier for me to see what's canceling here, and one set of x's, what do I have left? X times x is x squared in the numerator, and y is all that's left in the denominator. In other words, when I'm multiplying fractions, I can reduce any numerator with any denominator. All we do, since we multiply numerators and we multiply denominators, everything is multiplied together. Remember, this only works for multiplication, never for addition. When addition or subtraction's in there, this won't work for you. All right, let's look at number 5. I've got 3 fractions, multiplication of all of them. I can reduce any numerator with any denominator. You're looking for numbers that might have common factors. I see one. I see 5 and 20. I can divide them both by 5. 5 divided by 5 is 1. 20 divided by 5 is 4. I also see 11 and 22. I can divide both of those by 11. 11 divided by 11 is 1. 22 divided by 11 is 2. Now, everything else looks to be in its lowest form, so I have to multiply all 3 numerators. 1 times 1 times 1 gives me 1. And all 3 denominators, 4 times 7 is 28. 4 times 7 is 28. Times 2 is going to be 56, I believe is right. So the answer should be 1 over 56. Example number 6 looks a little bit confusing, but it's really not. It's a negative in front of a fraction, 2/3, which is raised to the power of 2. Now, 2/3 is raised to the power of 2, not the negative. The negative is just out front. So really what we've got here, I've written it with parentheses, but you could write it with a dot, a multiplication dot in the middle, and ignore the parentheses. What I've got is negative 2 times 2, numerator times numerator, over 3 times 3. Look, I only had one negative in the original problem. I've only got one negative in the ending problem, so I'm going to have a negative answer. It's going to be negative 4/9.